everyone. Thank you for joining. Welcome back to the next webinar in our Plantae Presents Global Plant Science Talk Series. All right, so without further ado, I'm going to hand it over to our wonderful moderator and Plantae Presents Steering Committee member, Gita Yadav. Gita is a lecturer in the Department of Plant Scientists at the University of Cambridge, and she is a scientist at the National Institute of Plant Genome Research in New Delhi. She will be introducing our speakers and collecting your questions. Thank you so much, Gita.
Thank you, Katie, and welcome everybody to the first part of Plantae Presents panel on specialized metabolites today. With that, we'd like to move on to our last and final panelist of the day, Emanuel Faria, who is the president and principal researcher for Verriclear Natural Skin Essentials Limited. Verriclear is a company that harnesses data mining to create effective phytomedicinal treatments for neglected skin diseases in marginalized markets and pervasive skincare needs globally. I got to know Manny several years ago when he wrote to me about the work that we had been doing on essential oil profiles, collating and creating, data repositories, public data repositories. And over the years, we've been collaborating, and I've totally loved his quick-witted humor, bordering sometimes on hysterical some days. And in fact, today he addressed one of my serious questions to Benji rather philosophically on the panelists chat box. He thinks others can't read it, but I'm making it public now, Manny. So Manny thinks that compared to dogs, cats are kind of depressive loners, and so it makes more sense that they turn to drugs rather than a thrown tennis ball. Okay, Katie, let's have his slides before this explodes altogether. Thank you.
Hello, my name is Emanuel Faria, and I'm the founder and formulator at Verriclear Natural Skin Essentials. For the past 2 years or so, I've been collaborating with Dr. Gitanjali Yadav and Peter Murray Rust. Today I have the honor of describing to you our work in progress, the development of an open source toolkit for searching and scraping high quality data from open science sources. The proposed toolkit, which I like to call Dave, is intended to download, abstract, verify, and extract high-quality open-source research data that can be relied upon for effective decision-making and action-taking. Now, the challenge that our toolkit is aiming to overcome is what I like to call the innovation bottleneck. You see, research portals like Europe PMC and PubMed are essentially vast catalogs of millions of research papers. And of course, while it's certainly desirable that the publication of new research continues, this exponentially increasing volume of accumulating research data has already drastically outpaced our ability to make intelligent or effective use of it. It effectively cripples our ability to leverage the existing research to discover and produce new and innovative solutions to the world's age-old and new problems. Dave will download hundreds, thousands, or even millions of research papers, automatically and intelligently analyze the corpus of downloaded papers to identify the relevant data points, scan them using custom dictionaries of categorized keywords, and even aggregate and reinterpret the data that is already contained in tables within each of the articles in a way that can be then output, uploaded, and integrated offline into whatever system or tool that researchers will use to make the decisions related to their desired outcome. So perhaps using the remaining time here, the best way to do this would be to take you right here to our GitHub repository and show you some of the dictionaries that we've put together. I'm going to go in here to dictionary. Inside dictionary, there's an index, and from the dictionary index, there is a description of each of the dictionaries that we have completed so far. One is called EO Plant, Essential Oil Plant. This dictionary has 1,678 plant names. They were extracted from the first 186 test articles that we downloaded from PubMed. So that's a lot of names in just those articles. And of those entries, 1,567 had their names normalized separately afterwards and tagged with corresponding Wikidata IDs that will also have descriptions. There's EO plant parts, geolocation. This is the area where the plants were harvested from, where they were grown, where they were processed. And this particular geolocation dictionary will include such data as the country name, the ISO code, the city, latitude, longitude, etc. Now I'll go back out and show you what the dictionaries look like. Compounds. Here is, think of it as a table. Each of these are columns. So the entry name is the name of the compound. The term is also could be exactly the same. Sometimes if there's more than one way to say the same thing, the synonyms, in other words, will have the term be the one that is chosen, and the name will be a synonym. This one has a Wikidata ID, and from that Wikidata ID, anything else about that particular compound can be linked back and pulled out later. We don't have to have it all on our drive or in these dictionaries. Target organism. Target organisms are the microbes that were mentioned in these same articles that mentioned an essential oil or plant name. So we would assume that research was done to see if those oils or compounds would have an effect on these various species. We have species of bacteria, fungus, and all of that takes us back here to what Get Papers downloaded, and here's the PMC ID number for each of those articles. And in this particular directory, as well as inside each of the different article folders or directories, there are now many more files with much more data that Amy has put together for us. And I don't have the time to go into the detail that I would love to right now, but I will show you one of my favorite things, and that is the co-occurrence tables. So for instance, binomial, and a binomial would be a microbe. So can we find a binomial and a compound that goes together, co-occur in these articles? And here we go. So it looks like Staphylococcus and acetate show up the most together out of those 186 articles. Carvacrol would be number 2 for Staphylococcus. Eugenol number 3, camphor number 4. So this is a good indicator that there are experiments being done. I would put my money on inhibit these different microbes. Now that you've seen the dictionaries, I want to show you a little graphical representation of how they will be used or can be used to identify data that might be useful to you. So starting with this case, we have plants. Plants have names. Plants are also comprised of chemical constituents, which also have names. Plants also have parts, one of the dictionaries that we had. Plants have material processing histories, geographic locations. They also have extract types, balsams, absolutes, essential oils. Extract types can exhibit various properties, such as properties that are useful for formulation. Properties can be chemical, density, color, smell. They can be functional. These extract types can also exhibit phytomedicinal activities. They could be antibacterial, antifungal, antioxidant, and also medical or traditional ethnobotanical uses, antacid, anti-Alzheimerian, herbicide. Whew. Well, I wish I had more than 7 minutes to introduce you to Dave and show you the many other different and useful ways that Amy can parse and display data, and to tell you about the many new features that Peter and the team are working on right now to make Amy even smarter and more useful. But if what I've shown you so far has already piqued your curiosity, and you're interested in learning more about Dave and our CEV Open project, we invite you to check out our progress at GitHub on the link below. We look forward to having it ready for you to put to good use in your projects really soon. Again, my name is Emanuel Faria, and I really hope you enjoyed watching this presentation as much as I enjoyed making it for you. Thanks for watching.
Thank you, Manny. That was really neat, and especially because I've been trying for many years to try and present my work, our work together as well, but I haven't been able to do that. So my first question to you is to get to know you better, for our listeners to get to know you better. So what was the first key moment in your life that turned you onto plants? And what about your current project? What is it about your current project that connects you to that moment?
Okay. First of all, I want to apologize for that little commercial at the end. I wasn't expecting that little window to pop up there on the YouTube. That was embarrassing. And also, hi, Dr. Gita. It's great to be here. And I wanted to say that I'm grateful to the people at Plantae.org for hosting this event. It's marvelous. And also to say that I'm really honored to be invited here on this panel today, along with my fellow botanists and scientists actively conducting research. And yeah, I hope I can contribute something meaningful, or at least accidentally, humorous to this conversation today. So turning to your question, I fell into this by accident, like most things in my life. It was 2008. I was the founder of a very large company that was affected by the global credit crisis. And every single day of that following 5 years of that catastrophic market meltdown, I experienced ongoing and also new overwhelming stresses every day that eroded every aspect of my health and ultimately compromised my immune system. And I ended up with a viral skin condition that, like many others, had no cure, and for me, no functioning treatment. So over the course of 2 years, I subjected myself to increasingly painful and really, really destructive treatments until one day my doctor just gave up on me and said, they literally told me to go home. And she said, I'll never forget it. Just look, we can't keep doing this because we're just making things worse. And just go home and pray that this, resolves on its own. And, obviously that wasn't something I could allow myself to do. There was just too much at stake. So I poured myself into PubMed and different clinical study databases to do the best I could on my own. And I felt like I was using a child's toy shovel on the beach, trying to mine through that literature for any signs of hope. But one of the first things I discovered is that all of the treatments existing for this condition, 100% of them, including cryotherapy, laser surgery, all of them work only 15% of the time. In other words, they fail 85% of the time. And the more I learned about that and began to see different patterns, it was kind of like that movie From a Beautiful Mind, although he was kind of nuts, where there's all those newspaper clippings on the walls, and he sort of sees all the connections like lightning going through them. And partially like that other film, Lorenzo's Oil, the true life drama of a father and mother who battled against the odds to save their son's life from a rare and incurable disease, right? But when all else failed, their persistence led them to a cure, which saves their boy and rewrites medical history. I'm hoping to do both, but at the time I was just worried about myself. So I formed a hypothesis and set out to prove or disprove it on myself. And I hyper-focused my search at that point, all the queries and parameters to include keywords like plant extracts, botanical compounds, phytomedicine, things like that. And I found that a few doctors had reported some success with just like one thing, just a certain plant oil, or for instance, just pure like vitamin E capsules that they would break open and put on a person's skin, and that worked. And from those few successes, I refined my hypothesis even more and then began searching for plant extracts that had certain constituents and properties and where I could find them, right? The activities. So it was really difficult to find that kind of information, which is how I ended up finding you on S-Oil. So I put together my first formula. It was 15 ingredients in a ratio that made sense to me, and began applying it twice a day. And 110 days later, all the signs of the condition were gone, even down under a dermatoscope or like a magnifying glass, that all of the line prints and the fingerprints had returned as if nothing had ever happened, which was amazing because by the end of all those treatments, it looked like I had leprosy. It was really bad. And so that's when I became a man on a mission. And so far, everybody's had 100% success with this product. And they've even found other uses for it as well, like acne and even under eye circles and things that I wasn't expecting. Well, I guess I could have expected it, but I was not focusing on that. Let's put it that way. So that's how I got here.
Lovely. So with this project now, with drug discovery, the way you're continuing with it, what's your biggest question that you feel driven to answer now, and why?
The biggest one that drives me bananas is not necessarily a question in botany, but in immunology, really, and that's inflammation. What I'm trying to do is, rather than the difference that I found is that all the other treatments were focusing on a symptom and not the root cause. And that makes sense because of the way that some of these companies are what their business model is, right? They they don't want to cure you, and I'm not a conspiracy theorist and like that. It just made sense. And so when I look at the situation, I look at it as syndromes, which are combinations of diseases. Diseases all have symptoms, and all those symptoms and the diseases themselves have pathogenesis pathways, and each of those have steps. And I look at it as, a three-legged stool. Why farmers use three-legged stools is because they can be stable on any surface. A four-legged one wouldn't, right? If you go to a bar or restaurant, you know that. And so I look at all of those different layers as if there were a pyramid of three-legged stools, and anywhere I can, I'm looking for a plant oil straight out or a component thereof that'll take out one of those legs on any one of those layers, so that thing will come crashing down, and then the skin can heal itself. But inflammation is a mess. Like, there's just so many pathways to it. And some inflammation points of it are good because they help in wound healing, and others are not. Where you can get into, as we know with COVID, but that's a whole other story. But with allergies and things like that, and so I look at it is a big map. If I had a map of New York City, let's say, and I wanted to block certain streets to keep terrorists from bombing some area, I also want to keep other streets open so that ambulances and fire trucks can get back and forth to the other side to keep people alive and the city going. So if I can find someone to help me figure out which of these things I can safely try to turn off and which ones just don't touch these, got to keep these lights as green all the time, no reds there, that would be a huge win for me.
And I think that's where we should be going with this project altogether. My last question to you is that your talk today, out of the four that we saw, was a refreshing advocacy for open science. And it reveals the extent to which full access to literature can truly change, especially your story about your own experience, how full access to literature can truly change the game for a researcher or an individual like yourself, looking to find patterns in large data sets or solutions to questions that you otherwise don't get. So with your experience, do you have any suggestions or recommendations for phytochemistry students starting to work on specialized metabolites? For instance, where could one find the most comprehensive repositories on active compounds in volatile emissions, for example, or anything else that you felt that you learned with your experience, which others starting out may not have at the outset?
Yeah, well, that's a good question. And it did take me a long time to get my way around it and see where to look for what. I didn't even know what searches to make. And the ones that I found kept leading me to, aromatherapy sites and things like that weren't useful at all. But governments have a lot of interest in creating databases for plants, particularly for agriculture, not only for growing the plants or nourishment of the soil, but also pest control. But also bioscientists have done an incredible job of creating genomic information and making this accessible. And each of them offers something that the others don't. So for example, the first one, the most useful one to me in terms of having plants and their constituents and their relative quantities, that took me a long time to find, was SoilDB, yours, Dr. Gita. And I'm so grateful for that and for you, because that's how I met you, of course. And it offers data that was manually extracted, from many text sources, and it includes plant names, the constituent compounds, the relative percentages, the plant material history, including geographical location where they were harvested, stress conditions under which they were grown, some activities as well. So that's very useful. That's at nipgr.ac.in/ESS for essential oil DB. ESSOILDB. Put that in the comments as well. The other one that I found recently, which would have been used to me a long time ago, was Dr. Duke's Phytochemical and Ethnobotanical Database. And it's a combination of some plants, some compounds, some ethnobotanical uses and activities, but it's not really in a usable format. But if you poke around a lot enough, you'll find something of use there. And you can find that at the USDA website. So just look for Dr. Duke's phytochemical and ethnobotanical databases on USDA website. Another interesting one for nutrients and composition would be Food B. It's like Food DB, but no double D. Food B, FOODB.ca. Very interesting one there. And another one is GRIN. GRIN stands for Germoplasm Resources Information Network. And that one is at www.ars-grin.gov. ars-grin.gov. So that's where I'd find information. And the other kind of useful tip or trick I'd like to put out to anybody, because I've been sitting in this chair for a long time, staring at walls of data and spreadsheets, and it's really tedious work. Cleaning up these databases and just finding out the dictionaries rather, and finding out which words are important. What do I want in there, and how do I separate them and classify them? And so, for someone who is little ADD, you might notice that, like me, it's difficult to concentrate. But I do two things. One is if you search for brain beats or binaural beats, you'll find some apps for that, which are really great. If you want, figure out how to write to me, and I'll tell you which ones I use. But basically, you know how dogs can only hear, dogs can hear certain frequencies that humans can't. Well, the way brain beats works is to get you into, for instance, an alpha state, brainwave state, or a beta state where you really want to be hyper-focused, or a theta state where you want to chill and relax and have ideas come to you. It'll play one frequency in one ear, a different one in the other ear, and then if you remember basic science about waves and troughs, it'll trick your brain into hearing and responding to, and then being entrained in that frequency. And for me, for focus and concentration, that has been, everything. And then the other thing is I have these hue light bulbs that I can change the color on, and I've been playing with certain frequencies, I guess, of light as well. But orange if I kind of want to like perk myself up, green for concentrating, red for really relaxing, and it's actually very good for renewing the cones and rods of your eyes. This is new research. So those are my two big things that I hope will help everybody to be able to stand, no matter how interested you are, but stand doing that tedious part that gets you to those dopamine hits every once in a while when you actually get to the destination.
All right. So in the meantime, what we're going to be doing is, while Manny goes and comes back, I think I would like to take a couple of questions for the other panelists. Can I request all the panelists to please switch on your videos, because I'll be asking questions to each one of you from the audience, essentially, that we haven't done earlier. And the first question is to Greg. Greg, this question has been put to you by one of our listeners, Samuel Smith, and he's asking you about whether you're planning to expand the metabolite marker profiling to other isoprenoids, for example, sesquiterpenes, monoterpenes, and so on. Would you like to take that, Greg?
Oh, in fact, no. We don't plan to do that, but maybe that our method can have the ability to quantify more than 60 compounds in one single run. But we are limited by the extraction. I think we use methanol, and maybe it's not the best solvent to extract monoterpene, for example.
Okay, you can take your time while I talk to Benji about a question that has been put to him by Brenda. Benji, the question to you is, it's again a cat question, and I know you must be tired of listening to more cat questions, but is it known how many species of cats respond to catnip?
Yeah, I think it's kind of the Felidae clade, which includes like panthers and tigers, yes. Leopards, and I think it's many cats. I think they've obviously, dogs aren't responsive. I don't think bears are responsive, but yeah. Lots of species.
You had mentioned this in your talk, but I still just asked the question again. Thank you, Benji. Manny, would you be willing to take the question that I typed out for you in the chat box? The question essentially was, about open science and about advocacy for using large-scale data-driven discovery for biology. So would you, the question to you again is, in large data sets, finding patterns that are useful for biology, to what extent do you think we need manual intervention to remove false positives, especially noting in your talk that you had ranked and in one of your co-occurrence tables, you had this improbable correlation between staph and acetate. You did mention a couple of things about it, but I would love to know the extent to which we can, rely on automated methods, and what kind of manual intervention do we need? Thank you.
Oh yeah, the mistakes. Well, there's actually two mistakes in that presentation I noticed. One was that I noticed that it said there was 1,600 plant names that came out of that first 136 test articles, but actually a majority of those plant names came from SSoilDB, Dr. Gita's database. So that was like the first seeds in our work there. Oh yes. So the thing about the acetate, right? That came up? No? Yes? Okay. Sorry, working deaf here. There's a number of things. First of all, that slipped my attention, but what's interesting is because it's open notebook study, it's actually how we work, where we make a mistake in real time and we learn from it and discuss it among friends and put it out there. We don't wait for 2 years to write something and then publish it. So you got to see that first thing. But first of all, because it was so late at night when I put that thing together, I picked the wrong folder, and that was actually our very first set of tests that we did. It was an old dictionary that wasn't normalized yet, first of all. Secondly, it was an old version of the software that picked up individual words instead of words that are together. So there are obviously various kinds of acetates that were being mentioned in the literature, but it was picking it up as a single word and putting that at the top because it came up so often, obviously. And I forget that last bit. But
no, don't worry about it. Don't worry about it. I'm going to be very short on time. We're running out entirely. So I would like to put my last question to Igor. And this question is from Benji. So Igor, Benjamin is asking, network analysis gives you more information than just using clustering?
Well, they basically provide you the same kind of information, how similarly expressed the genes are. Clustering actually provide you more information because it shows you in which tissues, let's say, or in which samples, how much a gene is expressed. Let's say that you have like a heat map and you cluster those genes and you have all the tissues in one axis. And the genes here in the y-axis, and then you can see the expression values more obvious that the network that just provides us whether two genes are more or less co-expressed. So you have advantages and disadvantages of both. I think in a way it's easier to represent a network with a lot of genes that you see the subclusters of genes which are interesting. They are clustered together with strong connections, and then you have other neighborhoods. But the clustering also can show you additional data with the expression values or how similar two genes are expressed. So you have advantages and disadvantages. You also can represent co-expression analysis as a list. So you can just have a list of genes that are co-expressed with your single. Of course, you have to select one gene, and you want to know which are the genes that are co-expressed with your target gene. And then you have a list of genes, and they are ranked based on the expression coefficient. So then you can have a list and see which ones are your interesting targets within this list. So basically you have lists, clustering, and networks that have advantages and disadvantages.
Thank you, Igor. And I'm sure Benji and you can get in touch with each other if there's more that you need to discuss. I would like to close now. Hold on. There is this comment by Amanda Storm. Well, she agrees with your cat hypothesis. I wouldn't have believed anybody would say that, but she does. So, all right, great on philosophy.
College knowledge, yeah.
The question she asks you is there anywhere that walks through or explains the process of using Amy? And I'm dying to answer that question, but you do it. You take it.
Oh, okay. The best place to look is to go on GitHub. And the link is a long one, and I have it here somewhere.
Go for
GitHub.com.
Okay.
Yes. Yeah. GitHub.com actually /PeterMR/openvirus/wiki/getpapers. Just a short one. Just a. But you know what? I'll put it. I'll paste it into the chat, and hopefully it'll show up for everybody.
And I'm going to request Katie to put it onto this answer box in the main Q&A. But essentially, Amanda, this work is being done live as we speak with Dr. Peter Murray Rust, who is at the University of Cambridge, and we've been collaborating for the last several years. This is fantastic amount of real open world science that we've been doing together in extracting knowledge from literature resources, open source literature. And you're welcome to take a look at Peter Murray Rust's GitHub repositories. All of them will give you enough information about Amy, but you're more than welcome to check out CEV Open. We call it CEV Open because it's about content mine. That's Peter's essential oil database, which is mine, and V for Verriclear, which is Manny's. So CEV Open is what works for us. Thank you very much. With that, seeing that there are no more questions, may I request Katie to take over? And first of all, thank you all of the panelists for your talks. And thank you all listeners for staying around with us here. I especially invite you to join us on part 2 of the Plantae panel on specialized metabolites on February 3, same time next week, same channel.